Okay, in the previous video, I made it up to defining what a mil was. And so I'm still learning this recording software, and I had to ended up having to start a new video. And that's okay, it wasn't really a bad spot to stop. But we have defined a mil, okay? And the reason that we want to define mils is somewhere along the line, somebody decided that if we can define area in circular mils as simply the diameter in circular mils squared, that could be beneficial to us. And the logic behind it is shown here in figure 3.5. And rather than trying to take that cross-sectional area, when we give it in the square inches, you're actually measuring it as a series of squares. And somebody has said that as a result, we can actually account for more of this area. If we use circular mils, you kind of lose this area here if you do it with squares. Supposedly that's what the reasoning is. So, but nonetheless, whether you agree with that or not, we are stuck with having to consider circular mils, because in the power field we have literally conductors, for example, 250 kcm, which stands for kilo circular mils, and 500 kcm, being 500 kilo, or 500,000 circular mils. Okay, and again, that is the area of that conductor in circular mils. Another very curious thing that comes up with this is, as I took these classes, we used to call KCM MCM. And you're going to have to get over this confusion, because they are equivalent, even though to you this means 10 to the 6th, and this means 10 to the 3rd. Kilo means 10 to the 3rd. You just got to kind of forget that M there, when it's next to MCM, really means 1,000 or 10 cubed. So 500 MCM is also equal to 500 kcm. I won't quiz you on that, or anything like that. That would be kind of mean, but you do, if you get into the National Electric Code and kind of into my world in the future, you become aware of that little thing right there. Okay, so with that in mind, let's take a look at example 3.1, where it says, what's the resistance of a 100-foot length of copper wire with a diameter of 0.02 inches? So we have some length of wire that is 100 feet long. And the diameter is 0.020 inches, which hopefully quickly now would be 20 mils, right? Okay. Then the area of that conductor in circular mils, you simply take that 20, square it, and I get 400 circular mils. An area. It did say that it's copper. And by the way, I abbreviate copper quite a bit as Cu, and that means that if it's copper, then rho is going to be equal to 10.37, and the units are circular milliohms per foot. And the resistance of that 100-foot piece of copper, that is 20 thousandths of an inch in diameter, would be rho times L over A, or 10.37 times the length, 100 feet. And remember, this is, well, let me back up a little bit, put the units in there. Circular mil ohms per foot multiplied by 100 feet and divided by 400 circular mils. Circular mils cancel, feet cancel, and we're left with ohms for units, and you get 10.37 times 100 divided by 400, and if the book is correct, that should turn out to be 2.59, and then that's ohms. And quite literally, then that wire electrically could be represented as a resistance and a resistor of 2.59 ohms. And quite literally, people actually use this when they're receiving wire on a reel. You can measure the resistance and work this backwards and actually anticipate or get an accurate measure of the distance. I know some commercial organizations, when they order wire like that, that's actually a requirement before they receive the order, that they measure the resistance, and it falls in between some levels so that they know they got about, if it's 5,000 feet, then they got 5,000 feet of wire. Okay, so that is that example. Let's go ahead and work another example. That is example 3.2. Where an undetermined number of feet of wire, and here's our receiving example, have been used from a 500-foot spool of wire. Find the length of the remaining copper if the diameter is a 1/16 of an inch and the resistance is 0.8 ohms. So they tell us that the resistance is 0.8 ohms. They tell us that the diameter was 1/16 of an inch, I believe, right? If we do that calculation, that is 1 divided by 16, that would give us 0.0625 inches, which would be 62.5 mils, right? And then if we square that, just go ahead and do that calculation. We get the area in circular mils. According to the book, that would be 3,906. 0.25 circular mils. Okay. Okay. So now we're given the resistance. We're given the area in circular mils. Our formula, R, equal to rho L over A. We know the resistance. Rho is a constant for copper. Let me just write in there a little Cu. And now we know the area. We are looking for the length. And if we solve that for the length, I would move this area over here, and rho would go to the denominator. And so I think if I was to solve that, I would get L equal to R, the resistance, times the area over rho. And so, let's see if we do this right. 0.8 times the area. Let's go ahead and put units in there. Ohms. When I put units in, it always helps as a kind of a second check. Times the area in circular mils, 3906.25 circular mils, divided by rho, which for copper, 10.37. And again, circular mil ohms per foot. And circular mils cancel, ohms cancel. And I always set a denominator, and the denominator gives me a numerator, so my units go up there. Multiply that out. And if the book did it right, they get a length of 301.35 feet. and that is the length of the remaining copper. Okay? Now, before we move on to example 3.3, we need to have this conversion, or show a conversion between square mills, and hopefully square mills makes a lot of sense if we have something that is by 1/4 inch by 2 inches. If we put those distances in mils, this would be 2,000. This would be 250. So 2,000 times 250. I'm going to bring my calculator up here. So 2,000 times 250 gives me 500,000, and that would be square mills. But since rho is circular mills, ohms per foot, we need to convert that to circular mills rather than square mills. And how do we do that? Well, if you look back on page 69, there's a conversion, and that conversion is 1 square mil is equal to 4 divided by pi circular mils. And I don't like leaving numbers in terms of pi, so what is 4 over pi? 4 divided by pi, bring the calculator back up. I'm simply going to do 4 divided by 3.414. We use 3.414 span pi equals 1.17172. 72, and so 1 square mil would be equal to 1.172 circular mils. A little bit of an interesting aside is, I don't know if you've ever heard this, but a good approximation for pi is 22/7, I was taught to use. Now, I just want to make sure that my 3.414 was correct. So, for pi, and I'll do 22 divided by 7. And, oh, it was 3.14, so I screwed that up. This is, then with that in mind, this is incorrect. And so 4 divided by pi is what? 4 divided by 3.14. 0.956. Did I get that right? I think that's right. Okay. Okay. So with that in mind, so this was 3.14. Let me do that again. 22 divided by 7. 143, actually. If I wanted to do that conversion again, I could do 4 over 22/7, which would be 28. 7 4s are 28 divided by 22. What's that number? Divided by 22. Enter. 1.272. 1.272. And I can see I still have this screwed up. Let's go back and do 4